Hi, this is Asing. You are now watching Asing Math TV. Today, I would like to share how to perform one sample t-test by using SPS. Firstly, go to Analyze, look for Compare Means. Click on one sample t-test. Move the variable of interest to test variable. Click on Options and check the confidence level. If we are asked to obtain the confidence interval other than 95%, we should change manually. Click on Continue and check the test value. According to this problem, we should take 169 as the test value. Click on OK and we should obtain the result. If we need more decimal point, double click on the table and select the values. Right click, look for cell properties and increase the decimal point. Also for the second table, double click, select, right click, cell properties and increase the decimal point. Now let's discuss how the values are computed. To obtain the confidence interval for this 95%, as we can see the value range from negative to positive value. However, if according to the formula, we should obtain this value, which is totally different from this. This is computed because of we have test value here. If test value is equal to 0, we should have exactly the same value. But now the test value is not equal to 0. To obtain the correct confidence interval, we should take the lower value plus the test value and obtain this, or the upper value plus the test value to obtain the upper limit. Or we can also apply the formula. What we have here is the sample mean plus minus the t-value times the standard error. The standard error is calculated by using the standard deviation divided by square root of n, which is 20. To obtain the t-value, we can make use of a new book, new data. Make sure the data view is not empty, simply type a number. Go to transform, compute variable, t as target variable. What we need here is the inverse df. Look for inverse t. Up. The first question mark is the probability. We should bear in mind that for any confidence interval, we should take alpha over 2, which means that for this case, supposed to be 0.025, which is 2.5%. Degree of freedom is equal to n-1, which is 19. Click on OK and we should obtain the value, as we can see here. To increase the decimal point, go to variable view and increase accordingly. Next, the t-value. To obtain the t-value, we can make use of the formula sample mean minus population mean divided by sample standard deviation divided by square root of n. To obtain the difference in mean, we can get it from here, or we can take mean minus the test value. df, which is the degree of freedom, is equal to n-1. 20 minus 1 equal to 9. With this t-value and the degrees of freedom, we are able to perform hypothesis testing by using the test statistics approach. From here, according to the question, we are asked to determine whether the mean height is equal to 169 or not. So which means that we should perform a 2-2 test. For 2-2 test, the significant level should be divided by 2, which is 0.025, and with degree of freedom, we obtain that the critical value is plus minus 2.0930, and the rejection region should be less than the negative or more than the positive. For the test statistics, we already obtained the t-value here. As we can see, the computed value is negative, which means that we should compare the value with the negative region. And we conclude that the value is greater than the critical value. In other words, the test statistics did not fall on the rejection region, and hence we couldn't reject the H0, which means that there is insufficient evidence, or what we call we have not enough evidence to conclude that the mean is not equal to 169, which implies that we can conclude that the population height is 169 to some extent, and the extent here is at 5% level of significance. On the other hand, to make use of the p-value approach, the p-value is calculated by using this test statistics. Since the value calculated is based on two-tail and what we want here is exactly two-tail, which means that we can take the value directly. We could also calculate this value by using SPS. To calculate the value, we back to data view, or we can straight away click on transform, compute variable. What we need here is the p-value. We can first reset or simply delete the previous numeric expression. Next, what we want here is to look for the cumulative distribution function, CDF, look for the t distribution up. The first question mark is the test statistics, which is 0.4146. Bear in mind that we should enter the negative value as well. Degree of freedom is 19, which is 20 minus 1. And what we need here is two-tail, which means that we should take 2 times the value. Click on OK, and we should obtain the value. As we can see here, also go to variable view to increase the decimal point if needed. From here, we can conclude that since the value is greater than the significant level, which means that we couldn't reject the H0 for the same reason. So which means that regardless which approach we apply, either the test statistic approach or the p-value approach, we should come to the same conclusion. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.